Okay, sorry it took so long. So what we're going to talk about then tonight is 3-3 and 3-4. All right, I have a little demonstration for 3-3. What we'll do is we'll kind of go over it a little bit, and then I want to come back. We'll write some things down, or I'm going to write some things down on here and also up on the board too, if you want to get them both. So yeah, we're going to talk about slope or slope of a line. Okay, it's a very important concept. All right. First of all, what I want to do is look at this. Okay, so this is a line right here, and slope is defined geometrically as rise over run. So when students first encounter slope, usually they say slope is equal to rise over run. So here's a line, all right, and it has a slope of 4/7 because the rise is 4 and the run is 7. So if I go from this point to this point, I'm rising 4 and running 7. That is called the slope of a line. Rise over run. All right? So I can change this line, okay, and keep the length of it the same. The slope doesn't change because it's still 4/7. But if I start moving it, changing it around a little bit, you can see that the slope is going to change. All right, so in this case, all right, here I have an 8 rise, 8 run, so that slope is 1. All right, so I keep changing it around. Here's a slope, rise 5, run 10, so that's a 0.5 slope. All right, so, oops, let me grab it again. Come on, grabbing the wrong part here. There we go. Now I'm changing it a little bit. I can make it a very, very small slope like that, so I'm 1 in 13. Notice that that's very small, which should make sense to you. A line that has a small slope has a very small rise, so it's almost horizontal. All right, it's almost horizontal. If I make the slope or the line almost vertical, then the slope becomes bigger. Here it's 3.5, which doesn't seem like it's very much. There's one at 7. Okay, let's see if I can bring this down here a little bit. I don't know if I can make it much bigger. That's a pretty, that one's 11, so you kind of get an idea of what those look like. So that's what the slope is defined as. All right, rise over run. Yes, sir?
So the rise is just the equivalent of the total distance traveled along the y-axis, and the run is just the total distance traveled across the x-axis.
Yep. Well, between 2 points, right?
Well, I mean, but yeah, total.
Okay. So hang on to that idea, all right? So slope is rise over run. Okay, so that's one of the ideas that we have. All right, that's what slope is. We're going to leave that idea there for a little bit. Also, what do we know about lines with small slopes? They are almost what? Small slopes, but how would you describe those lines?
Low.
Almost level, okay? So a slope of a line, actually let's just rephrase this completely. Let's say that, let's say the smaller the slope, I like what Brian said here, the level or flatter the line. Okay? All right? So I'm going to put in parentheses more horizontal. All right? And vice versa, if we have a larger slope, then what do we know about that line? Almost straight up, right? So then the larger the slope, the steeper the line, we could say. Okay, or more vertical. So those are some key ideas that we just gathered from slope right there. First of all, that it was equal to rise over run, all right? And then that we have the smaller the slope, the flatter the line, so the more horizontal it is, right? And the larger the slope, the steeper the line, more vertical it is. Right? So if you were a snowboarder or a skier or something like that, you can think about it as a nice level ski is going to have a very small slope because you're not rising very much or you're not falling very much. Whereas if you're black diamond like that, right, you're going to have a big slope because that's almost straight down. Okay, so those are those ideas right here. Comes from this. All right. So let's flip it around here a little bit. Let's say we have a line that is horizontal. Okay, so there's a line that's horizontal. It might be hard for you to see what the slope is there, but it's actually 0. Because what's the rise? 0. So there is no rise. So you can run as far as you want. It doesn't matter. Okay, it's just the slope is going to be 0. So then if I have a line that's horizontal, the slope is going to be 0. Vice versa, if we take this line and we make it straight up and down vertical, you notice down here in the corner that it says that the rise is 8, but the run is 0, so it says that the slope is undiff, which is undefined. Okay?
Is that 0 then?
No, because you can't divide by 0, right? Okay, because it's rise over run, and the run is 0. You don't go anywhere on a vertical line, straight down. You could rise as much as you wanted to, but you're not going to run anywhere. Right? So, if we were to write this down, okay, we would just say that a horizontal line has a slope of 0. All right? Horizontal line has a slope of 0. It's flat. It has no rise to it at all, which is why it has a slope of 0. All right? Okay, so these are all kind of ideas, and I want to make sure you get them, so I'll be more than happy to go through them again here. I'm going to kind of put little dots around them so that, little bullets, I guess we'll call it. Okay. A vertical line has a slope, and what do we say about that slope? Undefined. That slope is undefined. All right. Years ago when I was in school, we used to say there was no slope. In fact, I think I remember kind of teaching it that way, but that went away, and now we use the word undefined because in this case, okay, of this vertical line, there's a big rise, but there's no run. So you're dividing by 0, which you cannot do. So we call that undefined slope. Right? Okay, so those are some other ideas about slope that we get from this cool little document here that we have. All right, let's take a look at this. Now what I'm going to do is I'm going to bring this point over to this side here. Come on, grab that point hopefully, and I can move it. I'll move it back this way. Oh, come on, I just got to grab that point. There we go. Now I can swing it. All right, so now in this case, all right, it says the rise is 5 and the run is 3, but what it's not able to do, it's not able to tell us that the 3 is actually in the negative direction, but it does record the slope as negative. So this slope is negative. All right. So as you fall from left to right on here, the line is falling down. So if you go from left to right, the line is falling down. So we say that has a negative slope. All right. All the other ideas are the same. It's just that the slope is going to be negative. Okay. So a line.
As long as it's in the negative quadrant?
What's that?
As long as it's in the negative.
Well, actually, you could say that, but I could move this point over here.
And it's still negative.
Okay, and it's still a negative slope because it's falling downward, right? So if you go from left to right, you'd be falling down on the line, correct? Now if we swing it back this way, so now we're going left to right, we'd be going up the line. So that slope is positive, negative, and positive, right? Yeah.
Ever have to find the slope? Like the negative 1.25?
Uh-huh.
How would you find that?
How would you find it?
Rise over run.
You mean like if you were given a graph like this?
Yeah, and then they ask you just to find the slope.
That's great because they're going to. So what you'd want to do is locate 2 points on the line, all right? And like Nick says, you're going to count the rise and the run. So in this case, let's say I'm going to go from this point to this point here. So I'm going to say, okay, I'm going to go down 1, 2, 3, 4, 5. So that's down 5 over 1, 2, 3, 4. So my slope would be negative 5, 4.
And then divide them.
You can divide them if you want to. Slope can be written as a fraction or as a number.
Okay, okay.
So you don't have to divide them.
You don't have to divide them. You know, here's the deal. It's probably going to help you later on, not so much for this assignment, but other assignments, it will help you to divide them.
What if they ask you find the slope of negative 1.25?
Find the slope of negative 1.25.
Yeah.
You mean draw a line that has a slope?
Then how would you do that?
How do you do that? Well, can you wait a little bit and we'll show you?
Yeah.
Okay. All right.
Jumping the gun there.
Yeah, that's all good. That's good, though. All right, so then let's write down that a negative slope, and I think it's easier to kind of just draw one that has a negative slope. So if I did this, this is going to have a negative slope. Okay, that line is falling. Okay, you're falling down that line. All right. Okay, we are falling down this line. Right, so that is a negative slope, and then a line that is going this way has a positive slope. It's going up. It's rising. Okay? So we have lots of different stuff on slopes, right? Rise over run, okay? Almost flat, 0, undefined, negative, positive, lots of things about slopes. All right, so the next thing we're going to do is move on to this page here. Now this page shows 2 parallel lines, all right? Notice what their slopes are. What do we notice about these slopes? They're the same. And that should kind of make sense to us because these lines are parallel, which means they're not going to intersect. Okay, so their slopes should be the same. Now at some point I should be able to grab these. There we go. Okay, and you can see that since these lines are parallel, they always have the same rise and run. Okay, here the slope is 1, slope is run, 6, 6, 6, 6. It's all the same. They're going to have the same rise and run because they're parallel. Even if I go negative with them, they're parallel. So their slopes are going to be the same. That again is an important idea. So I'm going to write that down, that parallel lines have equal slopes. Yep. So parallel lines have equal slopes. All right, I'm going to go back to this thing again. If you want to see any of these, I'll be happy to go back to them. I'm going to go to this little page here. In this case, okay, now we have 2 lines that are perpendicular. Okay, so the slope of this line has a rise of 4, a run of 7. This line has a rise of 7 and a run of 4. So we want to know, well, what's the relationship in these lines? There's a 6:10. There's a 4:9. There's a 2:9. There's a 1:7. What's the relationship with these lines? 90-degree angle. What about their slopes? Opposite. Good. They are opposite. What else? What? Say it. It could be right.
One's negative, one's positive.
One's negative, one's positive. That's definitely right, but there's something else. Notice that this one here, what's the slope of this top line up here? What does it say it is? 0.3 or 1/3, right? What's the slope of this line down here? What does it say it is? -3. Okay. How about this one? I have 3/8. What's the slope of this line? 8/3. So what's the relationship there?
Reciprocals.
Reciprocals, right? So then what we have is we have perpendicular lines. So if they form a 90-degree angle, perpendicular lines, okay, have negative reciprocal slopes. So there's some really important ideas for us about slopes because that's what we want to know. Okay? We're going to be doing lots of little things, so we need to know those ideas. We got that all from this. I think that's the end of it. Yep, that's the end of it. Okay. So let's go back to kind of what Nick was saying before. I'm going to go back to this page. He was saying something about the distance between these points. I'm going to try to get this to be a positive slope. All right. So he was saying that, move this over here. Maybe I can just move this away from that text. There we go. Move that down. So he was saying something about, well, the distances along here is our rise and run. Isn't that what you were saying?
Yes.
Okay, good. So if we run with that a little bit, if we know the coordinates of this point and we know the coordinates of this point, right, how would we find this run here? Which coordinates would we work with to get that?
You can just walk across the x-axis until you connect with the other one.
Okay, so we're going to use the x-axis, so we would use the x-coordinates then, correct?
Yes.
All right. And what about for the run, or the rise, sorry, what would we use there then? The y-coordinates, right? Okay, so here's our question then. If we have a point that is 4, -7, and another point that is 3, 2, and we want to find the slope, I could graph it, right? Find the rise and run. We could do that. But if we looked at what we were just saying there, we got to find the rise. Which coordinates are we going to use?
Y.
The y's. That's these ones. Okay. So to find that distance that he was talking about across here, what would I do with those coordinates? What do you think we should do with them? How could we find that distance? After you do what with them? You got to find the distance, right? So if you're at -7 and then you go to 2, what's that distance? From -7 to 2?
9.
9. So what we're going to do is we're going to take these coordinates and we're going to subtract them like that because that's going to give us a -9. Now, how are we going to do it for the run? Which coordinates do we work at? The x's. All right. Again, we want to find the distance, so let's do the same thing. So we'll go 4 minus 3, and that gives me a 1. So there's my slope, -9 over 1.
And you can't find each one individually, right? The same thing, right? Or we should.
Yeah, you could, yeah. And in fact, what we're going to do is I'm going to go back up to here, okay, where I said that slope is equal to rise over run, and I'm going to write this, y2 minus y1 over x2 minus x1. And what that means is you're going to find the difference between the two y coordinates, right, over the difference in the two x coordinates. Yes, sir.
So, just curious. The first set of coordinates they give you, two sets, and they ask you if it's rising or falling. The first set is the set that determines if it's falling or rising, correct?
And the first set wouldn't tell you that. You're talking about just 1 point.
I'm talking about 2
Yeah.
points.
Oh, 2 points.
So when they give you 2 different coordinates,
Okay.
like 4
Okay.
and 7 and
Here we go.
3 and -2,
4 and 7. And what's the other one?
just shoot them off. 3 and -2. Or just-
3 and -2. Okay.
Theoretically speaking, well, technically speaking, the 4 and 7 would be the point that determines whether it rises or falls, because you're acting off of the first point, correct? Right, but that's your starting point. So
Here's
if it
4,
goes-
7 right
If
there.
it decides to go up from 4, 7, then it would be rising, right?
Okay, so here's 4, 7, right?
Sure.
Okay. So from this point doesn't really tell me anything about the line except I know it goes through it. Because the line could go this way, it could go this way, it could go this way, it could go anywhere, right?
Yeah.
This point tells me 3, -2, which is down here. Now I know where the line is.
And it's rising.
Okay.
Would it be considered rising or falling?
Well,
I think it would be rising.
what's happening if you go from left to right on this line?
Well, if you start with the first coordinate and you go to the second one, technically it would be falling, right? Because it's going down.
If you start from the first one here and you would go down for the rise, correct? I would agree with that. Okay, let me clean this up a little bit here. Let's run with this a little bit. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So 4, 7, right?
Yeah.
And 3, -2.
I was just spitting on the number two.
That's all right. Nothing wrong with those
Pick
numbers.
anything.
Okay, so there's my numbers, right?
Sure.
Okay, I'm going to draw this triangle here that simulates the triangles that shows the rise and the run. Okay, so from this point here to this point here, we're going to rise this much. But we're really going down, negative. From here to here, we're going to go back this way, right?
Right.
Which is positive or negative.
Negative.
So when you have a negative over a negative, what is that equal to?
Positive.
So it would be considered a rise.
Now, if I start here and I go up this way
So if you have
and then over this way, now if I go up, that would be what kind of a rise? Positive or negative?
Positive.
And now if I go this way, what do I get?
Positive too.
So it doesn't matter which points you pick to find the slope? Mm-mm.
So would it be negative if it's on the left side?
Okay, you're going to go up, right? That's your rise. And over this way for your run. Comes out the same. It should, because it's the same line. Slope's not going to change. That should kind of sit with you all right. I mean, you can pick any points you want on that line, you're going to get the same slope.
A question on your equation y2 minus y1. Does it matter which pair you use?
That's a good question, actually. So let's keep running with this one that Nick gave us, right? So he gave us
4 and 7 and 3 and -2.
okay, so he gave us 4, 7, 3, and -2, right? Okay, so if we want to find the slope, okay, we want to find the slope, we're going to go y2 minus y1, x2 minus x1, okay? Now, which one do you want to be, you pick a y2 for me. -2, so that means this one better be y1, right? Okay? If you pick this one to be y2, then you got to pick this one to be x2. Okay? Well, there's my 9, right? Okay? So now let's switch it around. I'll change to a different color here. So now let's switch it. So instead we're going to go 7 minus -2, right? And 4 minus 3, right? So it doesn't matter. But what does matter is if you pick this one to be y2, you got to pick that one to be x2. That does matter. Okay? Great questions you're asking. Great questions. Alright, so let's try another one. Same idea, we're going to find the slope. Alright, so we're going to find the slope of this. Okay? Alright, so which one's y2?
5
5
minus 4
minus 4. Which one is x2?
Negative 2.
Okay? 1 over negative 2. So it'd be 1/2 negative. That's my slope.
Can we graph that to replace it then?
0, 4 is here. Negative 2, 5 is up here. There's your line right there.
And you're always subtracting before you divide, right?
At the top of the page, for slope, you put y2 minus y, what was that? Equation.
y2 minus.
Oh, yeah, yeah, right, oh, the same thing, okay. Alright.
So the first part of the assignment that's on 3-3 is going to give you 2 pairs of points. You got to find the slope. Okay? y2 minus y1 or x2x minus x1. That's the best way to do it. All right, just use that idea. The second part of it is going to do exactly what Eric was saying. It's going to give you a line. So you're going to have a line like this. And it's going to say, find the slope of that line. The nice thing about it is it's going to give you a couple of points on it like that. And it's going to say, okay, find the slope. How could we find the slope of that? What's slope equal to? First thing we learned. Pick this point. How much do we rise to get to this point here? How much are we going to rise? Right there. How much is that? 3.
3.
How much is the run? 1, 2, 3, 4. What's the slope?
Right, 3 over 4.
Yep. All you got to do is count. There's a grid on there. All right. All you got to do is find those points and go. Okay. Again, what would happen if we would have went from this way to this way? Now we're going to go down and back. So how much do we go down?
Negative.
We're going to go down 3 and back.
Negative 4.
What's the slope? Negative 3 over negative 4, which is 3/4. See, so it doesn't matter which way you go. The slope is going to be the same.
Right.
All right? If I pick this point and this point, I'm still going to get 3/4. That line's got to have the same slope. Okay? All right? It's not going to change. Okay? A little bit like a pitch of a roof. Yep. Okay? A little bit like a pitch of a roof. Okay? Okay, so that's going to be, that's kind of things you're going to be asked about there. If we have a line, okay, and it looks like this, oops, straight like that, what's the slope of that line? Undefined, very good. We don't have to count anything because we know it's vertical, so it's undefined. All right. I can count if I want to. I can put points on there.
You're not looking for points, huh? You're looking for slope.
Yeah, you can put points on there if you want to, and you're going to find a rise, but there's no run, so it's undefined. Okay? Undefined. All right, let's see what we got here. There's some more stuff in this particular section. Going to give you some points. 4, 8, and 2, 10, and 1, 3, and 4, 7. Okay, the question to this is going to be, are these lines parallel, perpendicular, or neither? All right. So what it's asking is, it says, if you have this line here, and we have this line here, okay, so the line through this point, the line through these points, are these lines parallel, perpendicular, or neither? I could graph them, I guess. If I had good graph paper, I could maybe figure out whether they are. But I could also look at their slopes, because what are we going to know if they're parallel about their slopes?
Equal.
Equal, right? Okay, so let's find the slope of this one right here. We'll do this one first. Okay? So how do we find the slope of that? y2 minus y1. Which one's y2? So we're going to go 10 minus which one's y1? 8. Good. Which one is going to be x2?
-2.
-2. Got to be, right? She picked 10, so it's got to be. Minus 4. All right, so here we go. So let's see. 10 minus 8. 2. -2 minus 4. Good. Okay, so that's that one. All right, I'm not even going to bother reducing it because I want to compare them as a fraction. Here's an example where you just leave it as a fraction. Okay, let's do this one now. So, which one is y2? 7. Which one is y1? 3. 7, 3. Which one is x2? 4. And which one is -1 minus -1, like that? Okay. So, 7 minus 3? 4. And 4 minus a -1? 5. So, there's my two slopes. Parallel? Perpendicular? How do we know that? Got to be reciprocal. So there's this. These lines are neither. Okay.
When you were looking for the slope on the second one, she didn't have to start from like the 7 minus 3, right? She could have just did like x 3 minus 7, right? Would have been the same thing, right?
That's right. Again, it's the same thing as long as then this one's got to be -1 here.
Okay.
Okay. So if you're going to make this one your y2, then you got to make that one your x2.
The first.
And it doesn't matter. You can pick whatever one you want, but that's how that works.
Okay.
Okay. That's a lot of stuff on slope. Does anybody have any questions about any of the stuff that we did right there? A lot of stuff on slope.
I like the last test.
Okay. Now we'll see how where we go with this. The next thing we're going to do in section 3.4, you'll get a chance to practice some of these, of course. All right. You might recall that on Monday, I said, well, there are different forms for the equation of a line. One of them is this standard form, and one of them is this, what we call slope-intercept form. Okay? When we have a line in this form, this value right here, that is your slope. Okay? And this value is called the y-intercept. Now remember we talked about intercepts on Monday. Okay? So B is the y-intercept. So this kind of gets back to Eric's idea is, well, if I have a slope, can I graph a line? And the answer to that is, yes, you can. Remember that we had problems where we had to graph the line. Some of you probably did this on your assignment, okay? Although I know it's not due till next time. Had to make a chart, right? The little XY chart, okay? You don't have to do that to graph, okay? Now, I remember I taught math 65 one time, and on the first section of math 65, you get to graph lines. And so we were doing these, and these poor students, they thought that they had to plot points to graph lines. I said, I don't know where you got that idea from. You just got to use this. And they thought this was much easier. When you're using this to graph a line, the first thing you want to do is go to that y-intercept, which is 2. Okay? I'm going to go up to that 2 right there and put a point there. That is like an anchor point. Now the slope is equal to 3 over 1, because any number can be written over 1. So how much is my rise?
3.
How much is the run?
1.
So if I go from this point up, 1, 2, 3, and over 1, there's another point. Done. Okay, there's another point. So all we did was we're going to go to this 2, that's the y-intercept. We're going to go to this slope. Slope's 3 over 1. I start at the y-intercept, up 3 over 1. There's my other point. Connect your line. Okay, real easy to graph lines using slope-intercept form. Really, really easy. Y equals, that's a nasty one. Y equals 1/2 x minus 4. All right, so let's take a look at this line. Okay, where is, let's see, what's our y-intercept? -4. So I'm going to go down to -4, because it's a y-intercept right there. What is the slope? 1/2. So slope is equal to 1/2. So from here, what are we going to do? Up 1 over 2, draw the line. Done. Okay, much easier than plotting points, making that T-chart or XY chart and plotting points. Much, much easier. Much, much easier than doing it that way. Okay, find the y-intercept, find the slope, and use those things to get there. So let's do this again. Yeah.
So if the 1/2 was negative, you would add a negative to both pieces?
Actually, you're reading my mind here. Okay.
Thank you.
So let's go ahead and do one like this. Okay, so there's my line. There's my y-intercept. Y-intercept is how much? Notice that I'm highlighting or I'm underlining or circling, whatever you want to say, the sign that's in front of that. So if it's negative, I'm going to include it. It's positive, so I know it's a positive 3. That's where that y-intercept is. Okay, what's the slope? Negative 3/4. So, what's my rise?
4. Oh, wait, negative 3, I'm sorry.
Negative 3. So from this point, okay, not 0, 0. Many people will make that mistake because they're so used to plotting points and they've been told to start at 0, 0. That's where they'll start. But no, we're starting from here. This is my anchor point. Okay, so I'm going to start from here. We're going to go down 3, 1, 2, 3. And what's my run? 1, 2, 3, 4. There's my other point. There's my line. Okay, is the slope positive or negative? Slope is negative. Is your line falling negative? Is your line falling down? Yes.
Yes.
Okay. Okay. Use that as a check. My slope is negative, then my line better be falling down that way. Okay. If my slope is negative, it better fall that way. Okay. If it doesn't, then there's something wrong.
So if it's a negative 3/4, then you wouldn't consider the 4 negative also, correct?
All right. Now I'm going to try to confuse you here. All right. Let's say that we considered the 4 negative. So now the negative is going to flop down there. Okay. From this point, what would we do? Go 1, 2, 3. And then which way would you run? 1, 2, 3. Doesn't matter, right? Slope's still 3/4. Doesn't change on that line. Okay? Doesn't change. That's a good question. All right? Doesn't change. Okay. Let's see. Get rid of that. Get rid of that. Get rid of that. 1, 2. Get rid of this. Man, I got a lot of junk up here. Get rid of that. Get rid of that. Oops, I don't want that. All right, let's do. Let's see what we can mess around with here. Y equals a times x plus b. That's letter A. That's letter B. Okay, we're going to go to this. All right, just to demonstrate this again, hang on. Here's Desmos right here. Okay, so I wrote down y equals ax plus b, and a is 1. Watch what happens when I slide that around. You can see that as I change the slope, that line's changing. Okay, from positive to negative. All right, there's my 0 slope right there, horizontal line. All right, you can see this changing. Watch what happens as I change the b. What does the line do? What's happening to the line? The slope stays the same, but what changes in the line? Let's start here at negative 10. Tell me what it's doing. It's rising. It's going up, huh? Okay. So what does the B control in the line? The B is controlling how far up it is. Okay. So if you have a line that's like this, and you say, oh, I think I need to raise that line, then you need to increase that y-intercept. The y-intercept affects how far up or down the line is. All right? So I can tell you that on the test, there will be a question that looks like this. Y equals 2x plus 1. Write me an equation of a line. Write the equation of a line that is higher than that one. So if we wanted to write the equation of a line that is higher on the graph than that one, what would we change?
The 1.
So give me an equation.
Y equals 3x plus 2.
Correct. Okay, because you went 2x plus 2? going to change is that y-intercept. What if the question is write the equation of a line that's steeper than that one? Steeper. What would that look like? What are you going to change if it's going to be steeper? That's right. See? You change that a value, that slope, that's going to make it steeper. Okay? So what's one that's steeper? Y equals 8x plus 2. Okay? Steeper. Okay? The larger it is, the steeper the line. What if the question was write an equation of a line that slants the other way from this one? Now it's slanting the other way. What would that look like? So instead of slanting this way, we're slanting this way.
The negative sign.
Where?
Would be the negative on the -2.
So would it be on this guy or this guy?
On the 1. No. On the 2x.
On the 2x. Right. That one is going to be slanting the other direction. Okay. So those types of questions you can look for. Make sure you kind of have a feeling for that. All right. That's kind of going to be an important idea. It all just comes from this. Here's your up and down with your B. Okay. And you're slanting your line, flatter, steeper, negative, positive. Okay. Negative and positive. Whew. All right. Let's take a little break, 5 minutes, 10 minutes or so, and then I want to show you some more stuff on 3-4. Okay. Take a quick little break here.
Excuse me, I got a question. Is there a possibility that you would give a written equation which is, for example, would be y equals to 3x, and you would ask for y-intercepts and at the same time for the slope?
Yeah, they're going to do that.
You're going to have that as well?
Mm-hmm.
Because like right now, that equation is so obvious and we could know both variables and we could find out how to find out. You know
So
what I'm
you're
talking about,
saying what if you
for
have...
example, like y plus 3x, I mean y equals to 3x, yeah, that's all.
Just 3x.
That's
Okay.
all. And you will ask to
Okay.
find the
So
y-intercept.
what's the slope and what's the y-intercept? Correct?
Exactly.
That's what you
Correct.
want to know.
Uh-huh.
Okay. So what is the slope?
The slope should be 3.
And the y-intercept?
Oh, 3. So
What-
3
what-
by should be
What's being added to that?
x. So 3x, no?
Mm-mm. Mm-mm.
So again, 0. Oh, I see.
Mm-hmm. There's nothing being added to it, so it's just 0.
Be 0.
Mm-hmm. Yeah, slope is 3, y-intercept is 0.
So if there is no number on that side, we will assume that is 0. Is that what you're saying?
I'm saying it is 0.
It is.
There's no assuming about it, it's 0.
Uh-huh.
Yeah,
Sounds good. All right.
Mhm.
Thank you.
you bet. And graph. Yeah, what's up?
Okay, can I explain? Okay, this is the slope.
Yep.
So how can like find it here?
How do you find what?
Like in the graph.
How do you find the slope?
Yeah.
So the slope is 3.
Mhm.
Are you asking me how I would find a slope if I had a graph and not an
Yeah.
equation? Okay. Hold on. All right. We're going to go ahead and take a look at what happens when the lines are not written in slope-intercept form. So what if they're written in a form like this? Okay? And this is something you're going to be asked to do on the assignment. So it says write in slope-intercept form, state the slope and the y-intercept, and graph. A couple people have already asked me about that. Okay? What? The board's not on? Sorry. There we go. So we're going to write in slope-intercept form. Uh-oh, sorry. That's what you want.
Is that grades? I need to know my grades.
Can you go public grades? Public grades. Well, it's your G number, so it doesn't matter.
Yeah, it's your G number. Thank God. I lost my job.
Only for a few seconds.
I need to know.
I'd be...
Forgot to email you.
All right. Yeah, I was waiting for that. Okay, so write in slope-intercept form, state the slope and y-intercept, and graph. So what we're going to do is rewrite this so it is in the y equals form. So to do that, we need to add this 5x to this side. We kind of did this. Hold on. We kind of did this on Monday. Okay, so we got negative 5x plus y equals 8. We're going to write in slope-intercept form. That's the first thing we do. So we're going to add 5x to both sides. So we get that. All right. Next thing it wants to do, write down what the slope is. Write down what the y-intercept is. So what's the slope in this situation in this line? 5. What's the y-intercept? 8. So remember that the slope is here in front of the x. Y-intercept is the number there. Okay, there it is. Now we have that. We're ready to make a graph. All right. If you have graph paper, that's great. If you don't, you can just do these little hand graphs like this. They're just not real accurate, but that's okay. Y-intercept is 8. Oh, goodness. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. You can see how accurate I'm doing this one. And the slope is 5. So what do I do from this point?
Do you go down 5 or 1?
I think I'm going to go down 5 because I've already went up to 8 and I'm running out of room. So 4, 5, 6, 7, 8. So I can actually go down 1, 2, 3, 4, 5. But which way do I have to run then? I have to go to the left because I need this line to go up, right? Okay. So you could have went up 5 and over 1 this way. That would be okay too. I was just running out of room, so I couldn't do that. So what were we asked to do? We were asked to write in slope-intercept form, so I did. There's one answer. I'm being asked to state the slope and the y-intercept. There's that answer. And now I graph it. Okay. That's what it's going to ask you to do that. So let's do a couple other ones here, just so you can see some different situations. So there's that one. Okay, let's take a look at another one. Same thing. Okay, let's go 2x plus 3y equals 6. Okay, so now we have one like this. We're going to do the exact same thing. Right? But before we do, we have to solve this for y. So what are we going to move to solve for y? The 2x. We're going to have to move that over to here. Okay, you have 3y equals. So it doesn't really matter how you write this. I could go 6 minus 2x here. But a lot of folks kind of like it to be written like this. So it's easier for them to pick out the slope. Okay. but it really doesn't matter how you write it. Now we have to divide by this in order to get it right. Okay, so here's my slope. So what's the slope of this line?
Negative 2/3.
Good, so that's going to be right here. Okay, negative 2/3 is the slope. All right, what is the y-intercept of this line? 2. How are we getting 2? Because we're taking,
3 over.
right, 6 divided by 3, right? Good. So that would be 2. All right, so now I'm going to graph it. So I'm going to take this here, use my graph paper or my little fake stuff here. Okay, where do I start? Y-intercept of 2, then what?
Down 2 over 3.
Down 2 over 3. Again, it's got to be a negative slope, so that line better fall. Okay, that line better fall. All right, so again, I'm writing in this form here, okay, slope, y-intercept, and graph. Okay, it's going to ask you to do that. Okay, let's try another one. Let's try 2y equals x. Okay, so we have to write this in slope-intercept form. Oh, we're almost there. What do we have to do to get in slope-intercept form? Divide by 2, divide by 2. Y equals x over 2. Okay, how much is the slope? 1/2. What's the y-intercept? 0. Because we're not getting any, nothing's being added to that. Okay, so the slope is 0. Man, you're looking good, aren't you? Yeah, oh, man, I know. Well, you're not supposed to say that. You're supposed to say, oh, I knew that all along. My next stop is Harvard, man. Okay, so y-intercept is 0, so I'm going to start here at 0, and then what do I do with my slope? Up 1 and over 2. Okay, there it is. All right. Okay. So those are all the ones you're going to pretty much be asked. All right. That's a lot of stuff there. This is, this chapter here is pretty challenging. So, do you have any other questions about the slope-intercept form equation of a line?
Can you explain the second one that we did again?
That's this guy right here.
Yeah.
Okay, so I got to solve for y.
Okay.
So I move the 2x over. Okay. I divide by 3 because I got to get y equals, right? Okay, so the slope is negative 2, 3. And the y-intercept is 6 over 3.
And then you just
And then I went to 2 and then down 2 over 3 for my slope. Okay. All right.